ladies and gentlemen, you are, you are welcome to one of the, probably the single most important topic in quantitative research, in regression, in econometrics. That one can look at, and it is known as panel data econometrics. Most of the data we've had are cross-sectional. In other words, they are at a specific point in time. Okay, you organize something at a specific point in time. You try to make sense of information, okay, at a specific point in time. But normally, information is not at a specific point in time. If you look at coronavirus, for example, we can have data for coronavirus in 2020. And we can have data for coronavirus in 2021. The moment you get an extra year to the previous year, now you are in the world of, you move from the world of cross-sectional data to the world of panel data. So we'll start with the panel data econometrics by first refreshing our mind with what a cross-sectional data set is. What is a cross-sectional data set? Well, it's data you collect on households, individuals, companies, cities, countries, human beings, taken at a point in time, at a point in time. So in this case, the ordering doesn't matter. Okay, let's say that the first one is country Algeria. The second one is country United States. The third one is country Ghana. The next one is country UK. It doesn't matter the ordering because all of them are in 1 year. Okay. Then we have time series data. Time series data is where the observations on a particular variable, so let's say a particular variable like interest rate or like exchange rate, okay, or the money supply, those particular variable, the observations or many of such variables are happening over multiple time periods. Okay. So you are talking about like inflation in Ghana over 50 years, inflation in the United States over 70-year period. Okay. So one particular variable or variable that over a long period of time is not a matter of, more of such individuals. Okay. It's not more of the individual, but observations, okay, have one variable happening multiple time periods. But if you compare it with cross-sectional, it is the number of individuals that are multiple. So multiple individuals, okay, one time period. Whereas this time period, time series is multiple time periods, one individual. Okay, multiple time period, one individual. And then panel data will combine everything. Longitudinal data. Okay, that is where you have observations across time and across individuals. Observations across individuals and across time. So in this case, the entities across individuals and across time, and the time matters. So you don't just pick anybody anyhow. Time is important. I'll give you an example. Okay. I'll give you an example for us to even get it better. So in a panel data, we distinguish between a balanced panel and an unbalanced panel. Now, in a balanced panel, okay, remember, the individuals are indicated by I. Okay, so let's say individuals like company A. Okay, let's take banks. You're looking at all the banks. So I here is from 1 to N. So if the banks are 25, you're going to get 1 all the way to 25, and each one of them is an I. EcoBank is an I, so bank 1. Okay, GCB is bank 2. Okay, Stanchart is bank 3. Okay, APSA is bank 4, and then on and on and on and on until you get to the last one. But these banks are also happening over multiple time periods. So what I just said was their information in 2000. Now let's go to their information in 2001. When you go to their information in 2001, okay, so now we are in a different time period. So the time period is from 1 all the way to capital T. So if it is 2000 to 2020, then you're going to have what? 21 years of information. That's what it means. Now, what is interesting is what makes it balanced and what makes it unbalanced. Now, the balance is where the same 25 banks are appearing every other year with their data. Okay. So let's say you're collecting return on assets on each bank, total assets on each bank, deposits on each bank, okay, loans and advances on each bank. And these variables are appearing every year for every bank, for all the 25 banks. So there is no missing data. And this is called a balanced panel. Now, an unbalanced panel is where the first year you had 25 banks, all of them have got their data. But when we went into the second year, 2 of the banks didn't have data for deposits, and 2 of them didn't also have data for return on assets. So because of that, we cannot keep their deposits and their return on assets for the year 2018. We can't keep that. And so that makes that particular data set from 2000 to 2020, it makes that whole data set an unbalanced panel. Okay. So an unbalanced, so in the year 2018, the total number of banks will no longer be 25, but it will be 23 for that year. And if it, of course, it happens in other years, then we are going to have a similar thing of unbalancedness. Okay. Now, working with a balanced data set is beautiful because then everybody is appearing every year. But working with an unbalanced panel is very painful, okay, because you lose information. So this is where a lot of issues related to unobserved heterogeneity appear. So models that have been designed for balanced data work well. But now people are now beginning to look into models for unbalanced panel because most of the time it's not easy to get all of the data observations available. So that is the difference between balanced and an unbalanced panel. But whether it's balanced or it's an unbalanced, the thing is that you have data on multiple years. That's what is interesting. So what is the advantage of that? Well, Baltagi has defined and explained all of these things in a book. Okay. So let's look at some of them. One, if you have larger number of observations, what it means is that you are going to reduce the problem of multi-collinearity. Okay. You're going to have that. Okay. Multi-collinearity. You're going to solve that problem of that because it means that if one independent variable is correlated with another independent variable, the more we have multiple data, that correlation will diminish over time. Okay, so that's one. So it gives you more efficiency, which is the best linear unbiased estimator. It gives you more best. But here's a caution though. More data doesn't mean more information. Because you can have a lot of data and yet information is limited because there is heterogeneity. And you will come to understand this heterogeneity. Okay. Of course, as the name sounds, it means that there is no homogeneity. Sorry, there is no, yes, homogenization or homogeneity. Okay. Things are that. You see, the more you can take a particular bank this year, and by 10 years time, that bank is not the same bank in another year. Do you know that? So the bank in 2000, and yet 2010, that bank is not the same. So there is a different bank. So even though you're calling it EcoBank, that bank is a different kind of a bank from the bank when it was 2000. And yet you are looking at them at the same time, but they are not the same. They are heterogeneous. So there are kind of differences even for the individuals. Individual firms, they are different as the years, roll by. And that can cause some form of problem, which you got to deal with because you can't still continue to call me more or less like EcoBank when I have changed. It's like a human being with a name, Dr. Sarah. You have that human being, but that human being, when he was a child, he was not Dr. Sarah, he was a baby as Harry. And now he's the same human being, but you can see he's not a doctor, he's not a medical doctor, he's not a lawyer, he's not a teacher. He has changed. And these changes will have to be captured. And that is something that can cause some situation. The same thing will happen when it comes to the time. Okay. Now, another advantage of panel data sets is that it is more informative. It gives you more information, because what is happening is that it's examining more questions unaddressed using cross-sectional and time series. There's so many questions. Okay, so you told me that the company was looking good. The performance was good in the year 2000. How about the performance now? I don't know. But if you have panel data information, it will help you to identify the impact of actions, treatments, controls, the dynamism of the relationship. For example, there was a policy that happened in 2010. Okay, and you were telling me that that company was good. Okay, isn't it because there was a policy? Couldn't the policy have impact? It's because you have data, panel data. So panel data can help us to know why is it that there was a situation like that. The company was not good before, but now it's good now. What was the situation? If you collect panel data, it will unravel the secret that is there. Again, you can control for the impact of unobserved or omitted or unmeasured variables. And this is what we call individual heterogeneity. I've told you before, and time heterogeneity. Now, there are certain things unobserved. I'll take, for example, you want to look at the impact of salary, impact of wages. Let me see whether I can get an example here. Okay. Impact of wages on a person's income. Or let me put it this way, impact of education on a person's income. Okay. So let's say that a person's wage, I just want to write something. This is a wage. A person's wage is a function of the person's education. Okay. Your wage is affected by your education. Okay, good, super. The question is, so you are considering the education as an independent variable, isn't it? That is affecting the wage. So the higher your education, the higher your wage. Okay. But somebody may have not many years of education, and yet the person's wage is what? Is going up, holding all other factors constant. But there is something in there, unobserved, which you didn't consider. That person has got something we call ability, special ability when it comes to computing, which he didn't really have education for. A special ability. Some people are computer geeks. This is an unobserved factor. Unobserved. And besides, you probably could not what? Measure it. So it's unmeasured. And this becomes something we call an individual heterogeneity. It is something that is peculiar to that individual and or that particular person. And so it is affecting the wage. But you don't see, it's already affecting the education. So the person may have 10 years of education, and that guy has 20 years of education. And yet the 10 years of education has got an ability, and that ability is impacting a lot on the person and before the person gets the wage. So if that is the case, having panel will unravel that. Okay, having a panel data will bring about that unobserved individual heterogeneity. Now, it's not only individual, you can even have time. So there could be a situation where time can affect. For example, you have the return on asset of a company in the year 2000. Okay. But when you collect more data sets, you'll be able to understand the return on asset of this company, okay, for the year 2020. Okay. From 2000 to 2020, you could see that time, as time goes on, you'll be able to see that the return on asset is what? Is increasing. It is increasing or is falling, depending on the situation. Okay, so time is affected, but you have not captured time. Okay. A person is short, but it's because of the time you look at that person. You watch that child in year 2000 and he was short. You keep saying that he's short, but you allow time. Allow time, and you see that that guy is very tall. Now he's taller than his father because he's 20 years old. So the guy wasn't short after all, as you thought. Time, which is undetected, omitted, okay, unobserved, okay, or uncaptured. You are not controlled, or you're not taken into consideration time. That can affect the result. And the good thing about panel data is that it helps you to be able to capture all of these situations. Panel data can help generate more accurate predictions of individual outcomes. Okay. It can help you to compute statistical inferences, very, very good things like non-stationarity, because nothing is usually stationary. It can help you to capture measurement errors, to handle dynamic, regressors, or dynamic explained variable, dynamic response variables. Okay. And you can only handle that when in the world of panel data. So these are some of the merits or advantages of panel data that you have to note. So I want you to look at this data, which is a balanced panel now. Look at the data carefully. What makes this balanced? What makes this balanced? Well, look at it carefully. Look at it carefully. If I should try and zoom it a bit. Okay. I should zoom it a bit. And even further. If you look at this data carefully here, you will notice that the year, watch the observation 1, watch it. You have 1, 1, 1. So from this level coming, just squeeze it up. So when you look at this section up to here, you will notice that that observation is from 1980, okay, up to what? Up to 1990. Okay, it's from 1980 up to 1990. Now look at observation number 2. I mean, the variable, the ID2, the individual 2. If you look at the individual 2, the information is also from 1980 all the way to 1990. Look at that. All the way to before observation 3 starts. So you see observation 3 starts, and that is what? From 1990. Let me just use a different situation there. So observation 3 starts from 1980 here until it gets to what? 1990. So you can see that every kind of individual, every kind of ID, every kind of, if it is persons, okay, if it is companies, if it is countries, it has data. And what data are we looking at here? Well, when you look at it here, okay, let me just go back. When you look at the data is referring to GDP. Okay. So you have GDP, consumption, and price. Now this data, it is appearing, okay, between 1980 and 1990 for each particular data. And that is a point that we are discussing here. That is the most important point that we are talking about. So that makes it a balanced panel. Each ID, each individual has got 11 years of data. And the sample size here is 3. Okay? The total sample size is 3, but observations are going to be 3 times 30. Okay? So the observations will be 3 times 30, where the 3 is the individual firms. So you have 3 times 11 to give you 33. So you have 33 observations, okay, but you have 3 individual samples. 3 individual samples. So 3 individual samples. So sometimes we say that you have n individual samples, and then you have 33, in this case, 33 observations that are there. So that's a balanced sample. Now let's look at an unbalanced sample, an unbalanced. Now the difference, somebody will say the difference between a balanced sample and an unbalanced sample is that an unbalanced sample, the data doesn't appear. So look at this. This is also a balanced sample, but it's a balanced sample with missing values. So if you look at this one here, okay, you can see that the value is not available. The value for 1986 consumption is not available, but the person decided to still bring in the others. He decided not to make it what? Unbalanced. Okay. And you have another information here which is missing, and the person decided to still bring the others because it's got data for the others. And so the person decides that no, I want to keep it. And so it makes it a balanced panel with missing values. Okay. Balanced panel with missing values. Now let's look at another one. This is an unbalanced panel. This is unbalanced. Now, why? Okay, and watch it here. You have the information from 1980 up to 1990. Okay, you have the information from 1980 up to 1990. And you have the same information from 1980 for the second, okay, the second 1980 up to 1990. And then the third one, you have information from, so watch it. If you look at the first one, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, and then 1990. If you look at the second one, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 for that. And then you have this third one, 1, 2, 3, 4, 5, 6, 7, 8, 9. However, you can see from here that some of the variables are missing. Okay, they are missing, and it's not just for one; it's for every other variable. That's for GDP. If you go to consumption, it's also got a missing value. If you go to this price, it's also got a missing values. Okay, so this is an unbalanced panel. You're still keeping the information, but the information is unbalanced. It's not for one particular variable, which you can drop, but this one you can drop a lot of them, and so you have an unbalanced panel. Okay. So those are the information that you need to note right there when it comes to the types of. Now, majority of the time, and I'll tell you this here, if you look at this, majority of the time, you are supposed to even delete this information. Majority of the time, you don't have that, so you just have to remove that. Majority of the time, you don't have that, so you just have to remove that. Okay. And once you remove, then you have a proper unbalancedness. Then you have a proper unbalancedness. So those are the different kinds of, panel data types.